What are colligative properties? Colligative properties are properties of a substance that change when a solute is added to a solvent. For example, if we had a beaker full of water, under normal circumstances, it would have a freezing point of 0 degrees Celsius. It would have a boiling point of 100 degrees Celsius. But if we add something to that beaker, say salt, that salt hits the beaker and it dissolves into sodium and chlorine ions. And because there's a solute in the water now, the freezing point and the boiling point will change. The freezing point will depress. It will go lower. Depending on how much salt, it could go as low as negative 15 degrees Celsius. The boiling point will increase or elevate. It could go as much as 105 degrees Celsius. Here's the equation you use to calculate the temperature change when colligative properties are applied. For the freezing point, delta T, which is your temperature change, equals the dF of the substance times Kf, which is a constant, times the molality of your solution. For the boiling point, delta T equals dF, which is the dispersion factor, times Kb, which is a constant, times the molality of that solution. Now, what are each of these numbers? The dispersion factor refers to how many pieces your substance will break up into. For example, salt, NaCl, is made up of Na and Cl. So it will break up into 2 pieces, so it has a dispersion factor of 2. MgCl3 is made up of 1, 2, 3, 4 pieces, so it would have a dispersion factor of 4. Kf and Kb are constants. The constant for Kf is 1.86. The constant for Kb is 0.52. And little m stands for molality, which is still moles of your solute over kilograms of your solvent. So let's try some problems. Take out your equation sheet, or your practice sheet we have for this, and remember your equation. Delta T equals your dispersion factor times Kf or Kb times your molality. Let's look at the first one. What's the new boiling point if 2 moles of NaI is dissolved in 0.85 kilograms of water? Question 1. What's the dF? Look at your substance, NaI. How many pieces is it made up of? Na and I. So it has a dispersion factor of 2. Part B. Solve for molality. Molality equals moles over kilograms. How many moles do we have? 2. How many kilograms? 0.85. So 2 divided by 0.85 equals 2.4. Solve for delta T. Delta T equals dF, which is 2, times the boiling point constant, which is 0.52, look at the previous slide, times your molality, 2.4. 2 times 0.52 times 2.4 equals 2.5. That's how much our temperature is going to change. Now to apply it. Water should boil at 100. When you add salt to water, you increase the boiling point, so we're going to add 2.5 to it, and our new boiling point will be 102.5 degrees. Okay, let's try another one. What's the new freezing point if 150 grams of magnesium chloride is dissolved in 2 kilograms of water? Question 1. What's the DF? Look at MgCl2. It's made up of Mg, Cl, and Cl, so it has a dispersion factor of 3. Part 2. Let's change our 150 grams into moles. Grams to moles, we divide by the molar mass, which is 95.3. 150 divided by 95.3 is 1.6. Solve for molality. Molality is moles over kilograms. We know that we have 1.6 moles and 2 kilograms. 1.6 divided by 2, our molality is 0.8. Let's solve for delta T. Here's our equation. We have a dispersion factor of 3, freezing point constant, 1.86, and molality, 0.8. 3 times 1.86 times 0.8 equals 4.5. That's how much our temperature is going to change. Now to apply delta T, water should freeze at 0 degrees. We're going to depress or lower it. So we're going to subtract 4.5. So what temperature will our water freeze at? Negative 4.5. Okay, and that is your answer.